In this lesson, we're going to do several things. One of them is we're going to use reciprocals to solve equations. We're going to learn what a reciprocal is, and we're going to understand and use the distributive property. The distributive property, the second part here, is a review of something that we have been seeing or we saw when we were doing expressions. So this is not new, but we're going to learn how to apply the distributive property when we're doing equations. So for the first part with the reciprocal, we're going to start by understanding or remembering a couple of things about one-step equations. So we remember that when I have an equation of this form, 3b equals, say, 15, what I'm expressing here is that if I have three of the same thing, maybe three boxes, and I have 15 total, and each box has the same, the only number that is going to work here for this to be equal to 15 would be the number 5. And the way we do this up here is by dividing both sides by 3, by the coefficient, right? And this cancels out, and b is equal to 5. We have also seen this type of one-step equation in which I have that b divided by, let's say, 2 is equal to 4. And this is like if I'm saying that I have a box, that's my b, that is divided into two parts, which is this 2 here, and only half of it has four anythings. How many do I have in one box? And the way we do that, so if we have 4 here, then we have 4 on this side too, so the total is going to be 8. Algebraically, the way we do this is by multiplying both sides times the denominator, times 2 times 2. This cancels out, and now I have that b is equal to 4 times 2, which is 8. So I'm reviewing this because I want you to remember something. Here I have 3 b's, and I want to make this 3 into a number 1. So instead of 3 boxes, I want to have 1 box. And the way I do that with a number 3 is by dividing by 3, dividing it by itself. In this case, you have a 2, and you're multiplying. This 2 down here is not really a number 2. Because this 2 is at the bottom, this 2 is really representing 1/2. I am going to write the number 1 there, but it's going to disappear because that 1 is not really supposed to be there. Like, nobody's going to write it. So the way I turn 1/2 into 1 is by multiplying times 2. So instead of having half a box, I'm having 1 box. Instead of having 3 boxes, I'm having only 1 box. That is the objective. That's what I'm trying to do, is making this variable into one variable, okay? Only one version of the variable. So with this in mind, let's move on. What happens if you have the number 3 and you want to make it into 1? What do? You divide by 3, right? So if you have a 3 and you want to make it into 1, you divide by 3. I have a 3 divided by what equals 1? Well, by itself, by 3, right? If I have a -4 and I want to divide it by something and make it into 1, what is that going to be? -4, the same number, right? If I have 1/2 and I want to make it into 1, I multiply by 2. 2 times 1, 2. 2 divided by 2 equals 1. So all this is to show you, we have something like this. You're like, okay, miss, what are we going to do? Because if we only had the 2, that would be easy. You say, hey, miss, well, I divide both sides by 2, right? If I only had the 4, you will say, well, miss, you multiply times 4, right? So you know that if you have it like this, you would divide by 2, and if you had it like this, you would multiply times 4. What happens if you have both? So what you're going to do is you're going to use something called the reciprocal, and this is a new word for us, reciprocal. You're going to use the reciprocal of that fraction to make it into 1. What is the reciprocal? It's kind of the same fraction but upside down, right? This 4/2 is the reciprocal of 2/4. But remember, my friends, whatever you do on the left of an equation, you have to do on the right and vice versa. So I have to do the same thing on both sides. Okay? Now here, you're not going to do any operations. You're going to cancel out. The 4 cancels the 4 and the 2 cancels the 2. Now your m has been isolated. It's by itself. Now you're going to solve this part in the following order. Left to right, 8 times 4, 32. 32 divided by 2, 16. And that is the value of that m. Let's try another one. I have my 3/4 of m equals 6. I am going to multiply. This is a one-step equation. I know it looks complicated, but it's really one step. I am going to multiply this 3/4 by the same quantity, which is the reciprocal. So the reciprocal of 3/4 is 4/3. The same thing on the other side, 4/3. And now I'm going to cancel 3 and 3, 4 and 4. My m has been isolated. Now I'm going to solve in the following order. 6 times 4, 24. 24 divided by 3, 8. M is equal to 8. So now we have two-step equations side by side. We have worked on this kind of equation a lot. We agreed that the first step in a two-step equation is to add or subtract to get rid of the constant. In this case, my constant is on the left side, so I'm going to start by getting rid of that. So I subtract 5 on one side, subtract 5 to the other side, cancel out. I bring my 3m down. I solve this side. 20 minus 5 is 15. Now I have a one-step equation. The second step is divide or multiply to solve the equation. In this case, I have to divide by 3, divide by 3. So my m is by itself, and then I solve the right side. 15 divided by 3 is 5. This is also a two-step equation. I also start by adding or subtracting to get rid of the constant. So I'm going to subtract 6 on this side and subtract 6 on the other side. This cancels out. This looks a little bit different, but it's the same idea. The m divided by 2 comes down, and then I solve this side. 11 minus 6 equals 5. Now I have a one-step equation, and all I have to do is, that is not the time for you to go, that is the other thing, multiply both sides times 2. 2 and 2 goes away, and m is equal to 5 times 2, which is 10. So look, it's the same procedure, just that in this case I am multiplying both sides, and in this case I am dividing. Now what happens if you have a problem like this? So it's the same type of problem. I'm going to start by getting rid of the constant on both sides of my equation. This cancels out. This looks a little bit different. 2/3 of m equals 10 minus x, which is 4. And then you're like, okay, miss, what do now? I cannot multiply, I cannot divide. Yes, you can. You can, multiply times the reciprocal of 2/3, which is 3/2. Whatever you do on one side, you do on the other side, 3/2. This cancels out, and now you have that m is equal. You solve left to right. 4 times 3, 12. 12 divided by 2 is 6. M is equal to 6. Now there are some exercises for you to do in MathSpace if you were absent for this lesson, but they are there for you to use. The other thing that I said we were going to review was the distributive property. When we were working on expressions, we worked on something that looked like this: 3 times p plus 2, and that was it. You remember that? Those were expressions, and what we learned about that was that we could use the distributive property to simplify. So 3 times p is 3p, and 3 times 2 is 6, and because it's positive, I add. So that is what we did when we were doing distributive property. Turns out that we're going to use the distributive property also for equations. This is an expression. I don't have a way to solve this because there is no equal. But now I'm going to turn this expression into an equation. And the way I'm going to do that is by creating an equality here. So if I have this, now that p has only one possible value, which from my head I know it's 2, because 6 plus 6 is 12, and 3 times 2 is 6. But you don't have to do it that way. You can use your knowledge of pre-algebra to solve this. Where I have that 5 times m minus 8 equals 50, I can think about this. 5 times 10 equals 50, so all this is 10. So for this to be 10, what minus 8 is 10? It should be 18. I can do that in my head with mental math, but I don't have to. I can use the distributive property, which tells me that 5 times m is 5m. And 5 times negative 8 is negative 40. Everything else stays the same. And now here I have a two-step equation, my good old two-step equation. So I'm going to solve by adding on both sides. And now I have here 50 plus 40, which is 90. Now I'm going to divide both sides by 5. This cancels out. And 90 divided by 5 is 18. So the value of m is 18.